Students, today I am going to teach you linear expansion. When a body is heated or cooled, the length of the body changes due to the change in temperature. Then the expansion is said to be linear or longitudinal expansion. See here, this is a rod. When after heating, this will be expand till here. So this is known as the linear expansion or longitudinal expansion. The ratio of the increase in length of the body per degree rise in temperature to its unit length is called coefficient of linear expansion. The ratio of the increase in length of the body per degree rise in temperature to its unit length is called coefficient of linear expansion. The SI unit of coefficient of linear expansion is per Kelvin. The value of coefficient of linear expansion is different for different material. So the equation relating the change of length and the change in temperature of a body is given below. Delta L by L naught is equal to alpha L delta T. So alpha L is a change in length, final length minus original length. So final length minus original length is known as the delta L. L naught is the original length is the L naught. Delta T is the change in temperature, that is final temperature minus initial temperature. And alpha L is the coefficient of linear expansion. And next one is the superficial expansion. If there is an increase in the area of the solid object due to heating, then the expansion is called the superficial or areal expansion. So this is the area of the thing, and now we are heating, the area will be changed and it will be increased. So this is the expansion. This kind of areal expansion is known as the superficial expansion. Superficial expansion is determined terms to coefficient of superficial expansion. The ratio in increase in area of the body per degree rise in temperature to the unit area is called the coefficient of superficial expansion. Coefficient of superficial expansion is different for different material. The SI unit of coefficient of superficial expansion also per Kelvin only. The equation relating to the change area and the change in temperature, delta A by A naught is equal to alpha A delta T. Delta A is the change in area, final area minus initial area. A naught is the original area. And next delta T is a change in temperature, final temperature minus initial temperature. And alpha A is the coefficient of superficial expansion. Cubical expansion. If there is an increase in the volume of the solid body due to the heating, then the expansion is called the cubical or volumetric expansion. So here this is the one cuboid, and after heating it will be expand like this. So the difference will be the delta. The ratio of the increase in volume of the body. As in the case of the linear and areal expansion, cubical expansion is also expressed in terms of cubical coefficient of cubical expansion. The ratio increase in volume of the body per degree rise in temperature to its unit volume is called coefficient of cubical expansion. This is also measured in per Kelvin. So the equation relating to the change in volume and the change in temperature, same only. Instead of delta A or delta L, we should write delta V by V naught is equal to delta V delta T. Delta V is change in volume, final volume minus initial volume. V naught is original volume. Delta T is a change in temperature, final temperature minus initial temperature. And alpha V is the coefficient of cubical expansion. So different materials possess different coefficient of cubical expansion. See here, aluminium, brass, glass, water, mercury. These are all having different cubical expansion. Thank you, students. Read well, and this is a very, very important question. So you should know it thoroughly, and read well and subscribe my channel.